Okay, so in this video we're going to go over the graphs of the tangent and the cotangent. But just a reminder, when we were introducing these trig functions, we defined the tangent of theta to be equal to sine theta over cosine theta. And the cotangent is the reciprocal function. So we have cosine theta over sine theta. So, and again, these are periodic functions, right? They have a period of pi, excuse me. Okay. Now, we're going to learn to graph the basic functions using the unit circle. But before we get that, I just want to introduce just kind of an idea here. Since we are dealing with fractions that have essentially a variable in the denominator, we always have to be careful when we're dividing by zero. We cannot divide by zero. Right? So whenever we have some finite number, and we divide by 0, right, this is undefined. Okay, so we'll keep that in mind. So we'll notice here that when dealing with the tangent, when the cosine of theta is 0, then we're going to have an undefined value for our graph. All right. And another kind of property here is if we have some finite number and we divide by a very small number, right, that small number getting essentially closer and closer to 0, either positive or negative. Right? And depending on what the sign is to that is going to tend to go to infinity. Right? We just think of this as a very large number. Okay. All right. So we say it's equal to infinity, but again, infinity not exactly a number, more of a concept, right? So think of finite number over a very small number, we get a very large number. And we say as that number gets smaller and smaller, those values tend to infinity, right? They grow without bound, is what we say. Okay, so we're going to see how that plays into our graph here of the tangent and the cotangent. All right, so again, we'll start off here with our unit circle. I'll just draw here. And I'm going to draw here our quadrantal points. So this point is 1, 0. The point here is 0, 1. And as I work my way around, we get negative 1, 0. And then here, 0, negative 1. Okay, so I want to use my unit circle here to graph the function y is equal to tangent of x in my coordinate plane. Right, so here, my coordinate plane. Okay. All right, so we'll start here. Again, this is in radians, so this is x-axis, y-axis. Right in here, my unit circle. All right, so we want to see the period is pi, so by the time I make my way down to a half turn, right, pi radians, then I should have a complete picture of the graph, right? Remember, a graph is periodic, so everything else is just going to repeat itself. Okay, so we notice here, right, keep in mind y is equal to tangent of x, same as sine of x over cosine of x, right? So we're taking the ratio of these values. To begin with, right, the cosine of x is 1, and the sine of 0, cosine of 0 is 1, and the sine of 0 is 0. Now remember, 0 in the numerator, perfectly okay, right? All that means is that the value is going to be at 0. Now, as we work our way to pi over 2, right? We know that this is pi over 2. Here's where we're going to have our first kind of undefined value, right? Because when we reach pi over 2, we have the value for the cosine is 0, and I cannot have that as part of my function. Right? It is undefined. Okay, so what we have here at pi over 2 is going to be an asymptote. Okay, so now let's take a look at, well, what happens between 0 and pi over 2. Right, so as we go in our unit circle, we sweep out an angle from 0 to pi over 2. The values of the cosine, as we see, they get smaller and smaller, right? They're approaching 0, right? And the values of the sine, they're approaching 1, right? A finite value, right? So if we recall a finite number over a very small number, right? These numbers get smaller and smaller as I get closer to 0. We have a very large number. So what we see here is positive, and it grows here. Remember, never being part or crossing or touching pi over 2. It just kind of grows infinitely large, without bound is what we say in using math terms, but it just keeps almost asymptotic behavior as it gets closer to pi over 2. Okay? All right. So now let's figure out what happens between pi over 2 and pi. All right, so let's say pi was here. Oops. Excuse me. Excuse me here, I drew an asymptote, but that's not necessarily the case at pi. Right? If we notice at pi, we get the value of cosine is -1, and the value of sine is 0. 0 over -1, that's perfectly okay. That just gives me a value of 0. Right? But what happens in between here, right? If we notice once we're past pi over 2, right, the values here along the x, they're very, very small, but also negative. Right? Notice that's the one difference when I jump from pi over 2 on the left side here. Right? The values are small, very small, right? But negative. But what do we have here, right? Finite number, right? This sine value is also near 1, right? But it's a finite number. But this very small number makes this grow without bound. But in this case, it's not going to go up to positive infinity because the values on the bottom are negative and the values on the bottom are positive. So that leads me to an overall negative value. So we have this behavior here, where it goes down here. Right now, as it approaches pi, right, the values of x get bigger in the negative direction, right, and they approach -1. But the values in the numerator, the sine, they also get smaller and they're approaching 0, right, till they eventually get to 0, pi comma 0. Okay, so that completes one period of our function. Right. Now what we'll notice here is our next asymptote shows up at 3 pi over 2, right, where the cosine is 0. So at 3 pi over 2, right, and then once again this is periodic, so I already know what the rest of this is going to look like, right? This part, like here, it just continues along this case where the distance between these is pi over 2. So this is negative pi over 2. And then at 3 pi over 2, it continues that behavior there. All right, now these here are 2 periods of the function, but this goes out towards infinity where the period of length pi, right, and at the end of each of these periods we have an asymptote. Okay, so it looks like here we have asymptotes at x equals to pi over 2 and also plus or minus 3 pi over 2, plus or minus 5 pi over 2, etc. All right, another thing to notice here is the range. The values of the range go from -infinity to positive infinity. Okay. Okay. And the domain is wherever the function is defined, right? In other words, whenever the cosine is not these values, pi over 2, 3 pi over 2, 5 pi over 2, etc. Okay. So now let's take a look at the cotangent. So I'll start off again. I'm looking at my unit circle. So we got 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. Okay. All right, and then we're going to graph y is equal to the cotangent of x. And again, using the reciprocal identities here, this is cosine of x over sine of x. All right. All right, and again, the period is pi, so if we can determine what happens between 0 and pi, the rest is just kind of periodic. It kind of repeats itself. Okay, so here we we literally flipped the equation here. So what's going to cause us to have undefined values is whenever the denominator is 0, in this case, whenever the sign is 0. All right, so we see right away that happens at our first point, 1, 0, or the point we want to start with. So that means that this is an asymptote. Okay. All right, that x is equal to 0 is our asymptote. Okay, now as we move away from this, we see we get very small values of y, right? As here as we are around that value of 1, 0, the values of y are very small. And the values of cosine are some finite value, it's like around 1, right? Not quite 1 because we're moving away from it. But what happens is, again, they're both positive, but very small number in the numerator means our values kind of grow without bound on the positive side, right? And that happens, right, as we get close this way. But the further away we move from 0 towards pi over 2, right, that's where now we have in the numerator we'll have 0, and the denominator 1, which is fine, right? 0 in the numerator is fine. That just is going to give me a value of 0. So at pi over 2, the graph crosses the x-axis. Okay, now as we move past pi over 2 to pi, we get this negative values, right? Because remember here, the cosine is going to be negative, but the sine is still positive, but negative or positive, overall we get a negative value. Right, so it'll continue going negative, right? But as we get closer to 0 here, right, to negative 1, 0, right, the values in the denominator, they're getting smaller, 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 right? And again, 1 over, or a finite number over a very small number is a very large number in value. But since the values are negative, overall it decreases kind of without bound. And we have our next asymptote, which occurs at pi. Okay, so this encapsulates one period. So now we know exactly how the rest of this function will behave. Right, from here, and we see, okay, well then the next, we have these asymptotes spaced by pi units. So the next one would be 0 pi. In this direction, it'll be negative pi. And I know exactly what this looks like. Where the midpoint is, right, or the cross of the x-axis is the midpoint between 0 and negative pi, so that being negative pi over 2. Right, so you see the symmetry there. Okay. pi negative 2 pi. All right, and that is the graph of our cotangent, the basic graph. All right. Okay, so here we have asymptotes at x equals 0, as we see plus or minus pi, plus or minus 2 pi, etc. All right, the range goes from negative infinity to positive infinity. All right, and the domain is wherever the function is defined, right? So everywhere except at these points here. Right? Okay. In future videos, we'll look at, similar to sine and the cosine, how we can shift it vertically, horizontally, and these graphs don't have amplitudes, but multiplying by some factor outside here kind of stretches it. Looks like it stretches or compresses the values. Okay, and that'll be in a further later on in this module. Okay, thank you.